everybody, and welcome to the Reverse Engineering Plus Plus podcast, where we talk reverse engineering, forward development, RF, and pretty much anything that we can think of which is involved in hacky things and STEM things. Joining us today is Bradan Lane, who has just flown onto the makerspace in the last 5 or 6 years here and is known for his eChallenge coins. He's a big proponent of certain elements of UX design, and as we'll hear, persona development. For this one, we had initially started off as a 15-minute meet and greet just to say hello, see what we were going to talk about, but we instantly meshed and we just ended up rolling right into the show. So I'm going to start it off here, rolling kind of in the middle of action. Enjoy. I've been following you here for a little while, and I think I know you best, though, for your eChallenge coins, which have been pretty awesome. I first came across that, I think, in 21 or 22. But yeah, that and CircuitPython and being part of the Badgers group on Discord and all that, man, pretty awesome to have you here. And we really do appreciate you being here, man.
It's interesting you bring up the 2020 eChallenge coin, because the whole genesis behind that was 2019. I was no longer working and no longer really had a rudder as far as what I was going to do. And I knew friends of mine had been in the service, et cetera. And I knew about the story behind the challenge coins and the way they were used and stuff. And I said, with all the advanced tech and cyber divisions of every branch of the military, they really should have a challenge coin that is not just a piece of metal, but actually physically challenges them to do something. And so this notion of a digital challenge coin came to play. And I will totally be honest, in 2019, I remembered vaguely, like what a resistor was from high school. And that was the extent of my electrical experience. I hadn't done anything. And so I had this idea and I had absolutely no way of implementing it. And that's how the whole challenge coin came to be.
Hey, so zero electronics knowledge. You have some software development background and things like that. Tell us, what did you do in order to make that happen? Did you talk to anybody?
Thankfully, I got connected with a guy from the UK who does electronic design for his own business. And he was very forthcoming with answering questions and giving me tips and stuff. And so eventually I got the 2020 eChallenge coin created. There's another anecdote from that, which was I submitted it as a talk for DEF CON. That would have been what? DEF CON 27, 28. We just hit 32 minus 5.
Yep.
And they rejected it. And I said, not a problem. Could you give me some feedback on my submission, my CFP? And they are great. They actually collect written feedback from everybody who reviews every talk. And they sent it to me. And one of them was, even by your own submission, this is a niche and probably you're not going to be able to make any more than 5 of, which at the time was exactly true. The original concept for how the eChallenge coin was going to be fabricated turned out to be almost impossible. The side effect of solving that problem is how I became somewhat of an expert in design for manufacturing.
Tell us more.
I talk to a lot of people who build badges and stuff, and I go, whoa, great idea, but I'd suggest you tweak this and this because it's going to cut your labor effort for manufacturing by like a third. And so, I spend a lot of time working with other, badge makers and stuff on design for manufacturability.
And that all came from your original concept.
My original concept. It's a gorgeous, I have one of them. I have one of the originals, and it was actually a prototype. And so when they said, yeah, even by your own admission, you're only going to be able to make like 5 of them. I went, yeah, you're right. You're totally right. I ended up making 240 by hand of that first one.
240 by hand? Oh my God.
Well, no. So this is the funny thing about it is, like, I talk to people who, they're going, well, I want to get a pick and place machine and a reflow, and I'm going, why?
Yeah.
I mean, it's like, yeah, I'm an idiot. I've got an entire fabrication lab behind me right now, but it's like, no, you don't do that. Don't do that. But what I did do, and this also ironically dovetails into, it would have been the canceled DEF CON, so it would have been 27.
Yeah, because you later at 29 had that process that you shared on the hardware hacking village for your Porta Prog, right?
Yeah, and so in 27, I actually won the contest, the Hardware Hacking Village online contest for coolest project. And the panel even said what was really cool about my submission wasn't that I came up with a cool project. It's I came up with a bunch of cool tools for making cool projects.
Nice. Yeah, I loved seeing. I remember at 29, the video that you put out there for the Port of Prague. It was a great piece of kit to be able to, I think, program things in mass. And given what you've talked about so far, definitely makes sense.
So what I shared for the DEF CON 27 for the Hardware Hacking Challenge was a set of very cheap DIY tools I created. And when I talk to people now about badge making, and I'm looking at stuff online, now that I'm over on Blue Sky, I'm getting a whole bunch of new people that I never knew before. And so I'm actually resurrecting those tools. I'm recreating them from scratch so I can document, the tools and how they work and stuff.
That's great. Looking forward to seeing those. And when you do put them out, I'll make sure to try to repost either from the Blue Sky that we created or mention on the show. That's awesome.
With mostly some 3D printed stuff and a piece of oxygen tubing and a plastic syringe, you can create a set of tools that allow you to hand assemble, badges and stuff, even with small SMD parts like 0603s.
Mm-hmm.
I wouldn't try to go any lower than that with the tools I've got. The DIY tools.
Right.
But they allowed you to sit down and not go insane making 20 or 30 of something. I typically my sit down time would be 24 units, anywhere from 18 to 30. And so I created a whole bunch of these, very simple tools that dramatically reduce the amount of effort it takes to hand assemble a PCB. Now I've got 2 pick and place machines that are chained together serially. So they, one does one type of work and one does another, and an optical inspection station that's manual. And then it feeds into a conveyored reflow oven. It's
oh my gosh, that is the setup. I'm super envious.
I literally have a full assembly line sitting right behind me. But, you mentioned the Port of Prague. Well, the Port of Prague started out as the portable ISP. My little, it's a little candy bar type shape thing, and it had one button on it. And that was mostly inspired by something that Lady Ada had created for their manufacturing facility. And so then I created the Port of Prague and added UDPI support and a bunch of other stuff to it. Well, Lady Ada took my code and put it back into their stuff.
Oh, that's awesome.
Well, it gets funnier than that. So then during the whole pandemic thing, they needed to retool their programmers, and she came up with a way of bit banging USB on a Pico, and that's now how you can get USB host, on an RP2040, thanks to what Lady Ada had created.
I didn't realize that was from her.
It may be a combination of things, but a lot of what made that work and published code and everything else came from Adafruit, because now that's part of the tiny USB library. But anyway, once she created that, she designed what she calls the tester brains, which is a new code base that they use that can do SWD programming for SAMD chips and stuff like that. It can also flash bootloaders onto an RP2040. It can flash a bootloader onto, almost anything that will take an SWD protocol to it. But it can also program over USB by emulating file upload capability. Well, anyway, they created this box, this tester brains box, and I went, that's cool. And now that I'm doing a bunch of stuff right now with SAMD 21 chips and SAMD 51. I needed a way to be able to do programming and test over SWD and USB file upload and USB serial protocol. And so I took their code and rebuilt and created a whole new Port of Prague XL. And so now I've taken their code. Now it's my turn to come up with, add something to it and give it back to them.
So whereas it'll pick up where the old Port of Prague was. And what are there any types of, newer microcontrollers or newer systems outside of the ones that you'd used previously that you are making a foray into? Are you expanding eChallenge coins to include different chips because of that?
Yeah, exactly. When I did there's a whole set of stories behind the 2024 eChallenge coin, which though there are people who wished I would continue with that size, it's like, no, I'm reverting back to the smaller size for a couple of reasons.
Okay.
The biggest reason is I'm trying to dramatically drop the cost of the eChallenge coin to the point where I don't mind if I just give it away. So
Wow.
while I will while I will be selling the 2025 eChallenge coin on Tindy, and I will have probably unofficially some for sale at DEF CON, the bulk of the ones that I have at DEF CON will be, if I see somebody doing something cool, I'm just going to give it to them. Oh
man, that's super cool. Like a true challenge coin, right?
And yeah, exactly. And I will even do the whole handshake thing and that kind of thing. So to do that, I had to find a way of dramatically dropping the cost. And so the first tier to drop it, and I did this as a test with my, I do a Christmas ornament, Christmas electronic gift every year for friends and old friends and family.
Yeah, I've seen that one. It's got the toy soldier and there's 3, right?
Well, those are just ornaments, and actually there was the original one was the Christmas bell, and all it did is it blinked lights and played a little sound,
right?
Played a little tune. Then after that was let's see, the snowman is my favorite looking one.
Yeah, it looks pretty good.
And after that was the tin soldier, and that was actually a shrunken down replica of a wooden tin soldier that my grandmother made. Then for 23, I had a bunch of leftover 2023 eChallenge coins, and that was the one that looked like a Simon game.
Yeah, I remember that one. Yep.
And so I flashed it as just a Simon game and gave that out, and everybody just absolutely went crazy. They loved it. People going, yeah, we sat around Christmas Eve just playing that for like an hour and a half. And so for 2024, what I did was I did the hardware design for my 2025 eChallenge coin and used my Christmas ornament as a way of testing out everything that I had planned for it. So I ported the text adventure game from Python to C, which was a pain, but now that I've got it, I can use it.
Sounds like an adventure.
It was an adventure. Well, and I had to like port a lot of tools and stuff and if you follow me on Blue Sky, I'm starting to actually share how I write text adventure games, because that's my new thing. It's like people like the story challenges, but you either get it or you don't, and you don't read it a second time and stuff. And so while I love writing them, I wanted something that was a little more interactive and took a little while to get through and stuff, and you could get through part of it and not necessarily get through all of it, whereas the story challenges, you kind of had to, it was serial, you had to go through the whole thing. And so I wrote a text adventure game for 2024, and I wrote it in Circuit Python. Never ever do that.
I saw that recent interview you did. What was it, about 6 months ago on Circuit Python 2, where you were first getting into it, but you're saying now no go.
No. Circuit Python is great. Don't try to write an interactive text adventure game.
I see.
I ran out of memory. I had so much code in there just to handle failures of memory, because text adventure games use up a lot of memory.
Yeah.
Because they just have a lot of text and a lot of logic and stuff going on. And so, yeah, I worked with the Circuit Python core team on, failover scenarios and detecting memory problems and all sorts, and having to do it in threads.
Even more fun.
Yeah, even more fun. So no, don't ever do that. So getting it all ported over and writing new tools to compile all the data into a format that C and C++ could handle. I did so that I could then repurpose the text adventure game from the 2024 eChallenge coin into my Christmas coin. And also the Christmas coin allowed me to test some hardware ideas. So I'm really pushing, in the eChallenge coin space, I'm really pushing the aesthetic of a coin much further than I ever had before.
Yeah, the 2024 one looks sharp too, and it's got the nice little outline on the side. You know what I mean? So when you move it, that's super cool, and it definitely does look more like that classic coin.
Yeah, well, the Christmas coin goes even further, because the Christmas coin, almost the entire face is gold clad. There's no LEDs on the face. There's no vias. There's no traces. Oh my God, that's a pain to design. Routing a coin or routing a PCB where you literally have to be single-sided. Every trace has to stay on one side of the PCB.
So you don't go through any kind of design manufacturers to do that, though. Now that you have your own setup, you're able to basically do that in-house. Is that right?
Well, I still have to have the PCBs made, but I do all the population and test and programming and all that stuff in house.
Okay, gotcha.
And so on the manufacturing side, learn how to do some stuff, but the aesthetic side for 2025 is going to look just like a coin. It's going to be all gold clad, a little bit of black on it, but very, very little. Almost all artwork on the face. And to keep the cost down, it's completely static when you've got it in your pocket. It only comes to life when you plug it into a USB connector.
That sounds like an incredible undertaking.
Well, actually, it actually simplifies things because there's no battery, which means I don't have to deal with multiple voltages and stuff.
Mm-hmm.
But to get the aesthetic, it was a bit of a challenge. And again, the authoring process for text adventure games. But yeah, so I'm trying to get the cost down to the point where I can give them away. But I'm also a big proponent of, I hate the fact that how many people have a wall display of badges that do nothing but collect dust?
Yeah, I do.
Yeah,
I was gonna say, I don't have a wall display. I've got a bucket for every year I've went to DEF CON. Just have it.
And it's like, you pray you remember to disconnect the LiPo or pull out the batteries.
Oh, yeah, good point.
5 years from now.
Oh shit, that's a good idea. I need to go through those buckets now.
Yeah, exactly. And so that's sort of the other reason why I became a big proponent of CircuitPython, is because it allows people who really don't know how to code, or a lot of people who don't want to know how to code, to make just enough changes to turn something that is already pre-programmed into something that it does what they want. Mm. And so, like, for my Christmas coin, I worked through the process to make sure that hardware is supported by CircuitPython. And it's in the CircuitPython build process now, and you can download the firmware for it. And it has its own USB PID, and it shows up as when you plug it in for mass storage device to upload code to it, all that kind of fun. And so the second byproduct is, once you've finished the text adventure game, you don't want to play it again. You can nuke the Christmas coin, flash it with CircuitPython, and the most logical thing you make it do is a mute button for video conferencing. Yeah, like there should have been a gap in that.
Yeah, there's a little gap.
Yes.
Yeah. And so I've got my Christmas coin on my desk as a mute button for Discord live chat and stuff.
That is so cool. So basically, you have the coin, it's got the coin aesthetic, it's powered by USB, and you can redesign it to be what you want it to be after the con or the challenge or whatever is over. That is super awesome.
Exactly. It runs CircuitPython, so it doesn't have a ton of memory in it, but it's got enough that you can do. You could make a game in it if you wanted to, but the primary, the sample code that I publish is just to make it into a mute button for Discord or Skype or whatever you want to use it for.
So I did kind of like that about the DEF CON badge this year, is that you could just put a SD card that didn't suck in it and just drop Game Boy Color games on there and start playing them.
I've got to actually say, I've never, ever played video games, ever. I've never had a gaming device. I've never played video games. So I really do want to, put a quality. Yeah. So
you must have gotten so much done. My 3,000 hours in Kerbal Space Program is a big barrier to projects.
Yeah, it's like, I arrived at college or university my freshman year, and somebody goes, "Oh, what games you got on your computer?" I went, "Games." I have a compiler, a word processor. Yeah, it's like games.
I've got GCC.
Yeah, I mean, I've tried to play games, and my attention span on a game lasts about 7 minutes tops, and then it's like, no, I never play them again. I tried playing, what was it, Myst or whatever that was, and it's like, no, I don't
slow burn for a game.
Yeah, I'm sure. Yeah, but I mean, that does not interest me at all. It never has. And I keep following people who do a lot of gaming and stuff. I'm going, I really wish I could get excited about it, but no, I can't. I just can't.
That's interesting, because another area that you're super into is like UX design. So I thought that it would be part and parcel, at least for most of the artists and designers that I know, to be like deeply enmeshed in the video game world. So like on the UX design piece, what are the primary things you're usually thinking of when you're involved with those? Is it more like software for the person, the 300-pound gorilla is going to be coming into contact with the computer, or what do you have in mind there?
So I've been doing interface design for a number of years, and I went to a 5-day workshop on design as a whole discipline. And on the very first day, one of these inspirational instructors is kind of talking about stuff, and he showed a picture of just a normal everyday thing. And he goes, the problem you're going to encounter as you get further into design is once you see something, you can never unsee it. And it's like an aesthetic or something. And he was so true. Like, I got back home after the trip and I hopped in my truck at the airport and I looked in the rearview mirror, and I've got a corrugated aluminum, the diamond plate style aluminum bed cover on my truck. And I looked at it and went, oh, frack, those guys didn't line up the panels. And to this day, it's like 12 years later, I still look at that and go, why couldn't they have lined up the panels?
It feels like that with home ownership too. You know what I mean? You get in there and then you do a drywall repair and then you always see it.
And so for me, UX design is understanding the user, understanding what is intuitive to the user, understanding how they go about their day, what is obvious to them, what is natural for them, and then designing interfaces for product that requires very, very little training because it works the way they would expect it to work.
Right.
And that's really what the bulk of UX is, which is one of the reasons why I absolutely loathe Tesla. Tesla said, everybody will get used to this new way of doing it. I'm going, there's a reason the old way was done for a very long time. It's like they said, well, you don't need a center, you don't need a console in front of the driver. The having it in the center is it's everybody likes it. And I went, no. I don't know if you've ever...
Me too.
Well, yeah, and one of the things that I talk about is I rode motorcycles for years, sport bikes mostly. And one of the things that any instructor will ever tell you is look into the turn. The bike will go where you're looking. And sure enough, if you go into a turn too fast and you're afraid you're going to go flying off the edge, exaggerate your look into the turn and you'll make it through almost every time, unless you hit sand or ice or.
Yeah.
And so if you take that, which is a tried and true piece of data, and put it in a car, you're going to go where you look. Well, if you're looking to your side, you're going to veer occasionally to the side, which is totally wrong. So yeah, it's, user experience is about understanding what works for people and then designing software to work that way, as opposed to trying to constantly teach people a new way of doing stuff, which is why one of the most fundamental skills of user experience design is building personas.
I think I know where you're going with this one. As a matter of fact, I'm glad you brought it up because I think you've used personas and things like that in some of your designs, or you used them with the coin challenges. So tell us a little bit about personas.
So a persona is a fictitious person that embodies a lot of characteristics of real people. And in design, what we will typically do is we will create and flush out to incredible detail a persona. And then we can say, okay, we're going to do this change and stuff. Well, how's Sarah going to react to that? Well, we know Sarah inside and out. We created her, right? We know what her daily routine is. We know where she lives. We know what she does on her weekends. We know everything about Sarah. So we can take that persona and apply it and say, well, okay, we can ask the question of ourselves. Since we created Sarah, we can ask ourselves, well, what would Sarah do in this case? I thoroughly believe, but I've never been able to dig into it to any length of detail, is what UX designers do with personas is ostensibly what social engineers do to go on a fishing expedition with a company.
Oh, that is an interesting Venn diagram of people there.
I think it makes sense though, right? Because you're just trying to figure out what somebody's reaction to a thing is going to be, and then exploit it. Right?
Exactly.
You want to get ahead of them in that.
And so we're doing it so that we can build better software, and they're trying to do it so they can exploit it. But I honestly believe, but I've never been able to dig into it to any length, to any detail to confirm that they're ostensibly the same skill set.
No, that kind of makes sense to me too, because there's there's been some stuff, not necessarily in a lot of spaces on the internet, but talking about things like dark UX design, like the idea that some places will design their UXs specifically to kind of keep you inside. You know what I mean? They'll swap the standard cancel and OK button location so that you
don't get me
mindlessly
into don't get me into that one. I saw one the other day that the way the text was worded, turning it off enabled the feature.
Yes, I hate that. It's like, was this designed by a politician? Like,
Yeah.
why would you do it this way?
Yeah. But anyway, so as an example of taking a persona to its nth level, Cladlo, who is the protagonist in all my stories, I can tell you almost everything about her. I can tell you where she lives, what her apartment is, where her favorite restaurants are, what she likes to eat, what she doesn't like to eat, who her parents are, what her parents did for a living, where she grew up, what her grandparents and her great grandmother was. It's all there, because over the course of building out all those stories, I had to keep pushing and expanding on my understanding of who this person was. Matter of fact, I just realized the other day that, she turned 31 last year.
Wow. So
she's no longer in her she's no longer in her 20s.
She started long before your eChallenge coins then.
Yeah, I actually know who her college roommate was, and her college best friend, and where she went to school. And yeah, well, I had to, because the 2020 eChallenge coin, she's already in her, her own self-created entrepreneurial career.
I see. Yeah.
So she'd already gotten out of college, and she'd already, so I still love that story. I think that, Sarah and the Deleting App is probably, it's not the best story, but it's it's up there. The second year, sort of the sophomore year story, that was kind of weak. I didn't do a very good job testing that story out.
I popped into there around the 2022 one, and I think I had gotten about halfway through around to like the UART piece with the Caesar cipher and stuff like that. But I had been brought up to speed a little bit by a couple of buddies who had kind of been there from the start and knew it. And yeah, I've loved it ever since.
2022 was Sarah and the Nightclub Riddler.
Yep.
One of the funny ones about that one is if you get to the third challenge in the story challenge, it's one of those head fakes.
Right.
You get this text message, and the whole clue is right in front of you. You go, what is the answer to it? And it's like, you missed it.
Yeah, no, it's a pleasure. That the gamification of it, along with like the physically actually having the token, is something I wish you'd see, frankly, more often. To your earlier point, when you had mentioned for having the challenge coins, they should do something. I've always loved the idea of that. And the badge life, of course, as you well know, has taken completely off in DEF CON and other, conventions and stuff like that too.
Oh, it's crazy. I did all the design. Well, I did 3 badges last year for DEF CON. 2 were related. One was completely different for a DEF CON group, DC 540. I did all the hardware on that design. And then it turned out that I collaborated on like 3 or 4 others to help people get over major hurdles they were running into.
You're saying during the design process leading up to?
Yeah, well, remember, one of the things I started off talking about was design for manufacturability, and
right.
One of the badges. I don't know if you saw the Mad Hatter badge.
I don't think I did. You see that one, Del?
It was cool, multi-layered.
Sounds familiar.
And it had the Mad Hatter 3D printed hat in the middle, and it had a little display in the bottom of the hat. And
yes.
Yeah, very cool. Very cool.
Look at anybody with it or anything, but like I didn't interact with it.
Yeah, no, I mean, I haven't interacted with it either, because I was working at DEF CON, and one of the creators of the Mad Hatter badge came up to me, and they gave me one, and they said, "Thank you for the help. We wouldn't have gotten it done if you hadn't helped us." And I'm thinking to myself, what the hell did I do? And they'd had a manufacturing problem they couldn't get over, and so I spent about an hour and a half. I said, if you don't mind sharing your design files with me, send them to me, zip them up, private message, however you want to get them to me. I'll take a quick look. And I, cracked them open and messed around with them until I found what the mistake was, and corrected it and sent it back to them and said, okay, here's what the problem was. Here's how to avoid it going forward. And they were able to get through the rest of their manufacturing from there. And it's like, I totally had forgotten I'd even done that. It was like, some Saturday morning kind of thing for me.
So I am massively fascinated in your 2019 year. So going from knowing about resistors from high school into getting into manufacturing, like your first prototype and design, could you walk us through as much as in detail as you can recall what 2019 kind of looked like for you, like as you learned along the way? Like,
there was a couple of things. One was I'd already figured out that, okay, I wanted to do something that had interactive capability to it, but then it's like, well, but there's only so many interactive challenges you can do at some point. Because originally I was thinking like cryptography and decoding and stuff. And so I said, I knew it was going to have some sort of a serial connectivity to it. So I knew I had these two buckets that I could work with. And then I realized that because we all thought we were going to be at DEF CON 27, I said, well, it'd be really cool if there was a bonus where you got coins to talk to each other. And they don't have to say, you just have to, like, you know, send a handshake. That's all I really need to do. And so then it came to, okay, well, how do I get these things to talk to each other? Wow, I'm running off a coin battery. Oh, power management, by the way, was a huge one.
I bet.
And it drives me nuts how inefficient most badges are when it comes to power.
You get the cursed knowledge now.
Designs right now. Yeah, I know. Well, yeah, it's like, you know, I'm working on. I got hired for a gig to do a badge for, I think it's a conference in Asia Pacific somewhere, like September. But one of the questions I said, well, how long does the badge have to run for? And they went 6 to 8 hours. And I went, yeah, it doesn't sound right. And so I looked up the conference and found out how long it was. And I said, well, we really need about 20 hours to get through the conference. And so I set out saying, okay, well, how can I get, and similarly for the eChallenge coin, I needed it to run for at least 3 days off a coin battery. And so I had to dig into data sheets for the first time in my life and sleep modes and all this stuff. And so one of the things I found out very quickly was most of the easy to use libraries for coding, A, they're fat, and I was going to run out of space pretty fast. And B, they don't give you access to the low-level stuff that the chip supports from the manufacturer.
Right.
So I ended up writing an entire low-level subsystem, and I was able to use it and modify it over the years.
So that
so power was a big issue.
From that time frame, you're still using that kind of what you came up with and designed from that time, and that's carried you forward throughout.
Well, so yes and no. I used that code base in 2020, and then 2020 was also the great chip shortage, and so
right.
I have historically had to jump chip from one chip to the next ahead of the curve, which meant before most people found a chip that was popular, I had to already be using it because it was the only chip I could get my hands on because no one else had discovered it yet. You know, so for instance, I couldn't get the chip from 2020 the following year, so I couldn't reuse any of that code, but I could reuse what I'd learned from writing that code to write similar code because I stayed within the manufacturer's family of chips. And then similarly, that happened again between 2021 and 2022. But thankfully I was able to reuse that chip between 2022. No, I wasn't even able to use it between 2022 and 2023. I had to change again. And now I'm in the same boat. As a matter of fact, I've got a call with Microchip on Tuesday of this coming week to work with one of their engineers to try to figure out how to get my development environment up and running on their latest chip, which no one has support for right now.
Wow. So you basically have to kind of predict what you're going to have and what you don't have, and then just adjust fire as needed, in this case for the development environment. That's wow.
Yeah. So back to your original question about, you know, what went into it. So I started out with a breadboard. I needed a chip at the time because, again, I hadn't even written I'd never written firmware before. Good grief. You know, I'd been working on big corporate industrial size systems, you know, massive servers, multi-server configurations. So I found a chip that was available in DIP format. Those are the ones with the long legs on them, so you can plug them into a perf board.
Yep.
I mean,
the sockets.
A breadboard.
Yep.
Yeah. And so I got that up and running with Blink. You know, it's where everybody starts. You start with Blink.
Like hardware, hello world.
It is. That's a great example. Blink is the hardware hello world. You know, and that's when I started learning about microcontroller clocks and the fact that your math for Blink changes depending on your clock, right?
Yep.
So if you've got a clock running at 8 megahertz and you want something to blink once per second, that's a different formula than if your clock is running at 2 megahertz and you want it to blink once per second. And that's also where I discovered that while most people are always looking to overclock their chips or at least run them at max, I'm always looking to underclock my chips because, for instance, a typical microcontroller, 8 or 32-bit microcontroller, might be using 10 to 12 milliamps at normal clock speed. But if I can take a 20 megahertz clock and run it at 4 or 5, I'm down to like 2 milliamps. That's a 5-fold improvement in performance. I can run for 5 times as long. So I'm constantly declocking my microcontrollers to get more battery time out of them. And so I had to figure that out and figure out LEDs and then figure out serial communication. And then the big hurdle was, how do I do this bonus, the handshaking? And that's where I ran into, I'm going to have to look up the guy's handle again. Smash Cat from the UK.
Okay.
And he got me digging into how to convert UART to IR. Now, I've subsequently learned that you shouldn't do it. But for 3 years for 3 years I did it. Actually, for 4 years I did it. The reason why is it's very short distance. It's great because the entire conversion happens in hardware. So to the microcontroller, you're just talking UART, serial. And then it converts in hardware and it works. It spits out over, a phototransistor on the receive end and an IR LED on the transmit end, and the opposite on the other side. And then it's hardware again. And then it just goes into 2 UART pins on the microcontroller. And you can send any data you want at that point. But it was, it was a lot of Q&A with him to figure out how to get that to work, because I didn't understand how transistors were going to behave. Because if you ever look at an oscilloscope of IR, it's very rounded on the edges and kind of sloppy and noisy in the middle and all that stuff.
Yep.
But by running it through a pair of NPN transistors, you get a nice square wave out of it again.
I'm curious. We did. I had mentioned, I think, in our comment, but we had back a while back for the DC DarkNet badge. They had a similar setup, I believe, with their IR receiver as well as LED, and we were trying to brute force like all of the pairing connections so we could get max points. I think tiny encryption algorithm is what they were using. Something really small and something. This was like a decade ago.
Well, actually, encryption algorithms is the other thing I had to figure out. So originally, in one of my prototypes, I had to get the story challenge to fit. It was in a flash memory chip off on the side. Well, that turned out to be a nightmare to program, because I had to first program the microcontroller and then kick my firmware on the microcontroller into a mode where it would read data over serial and then flash the pages into the flash memory chip. And it's like, thank God I abandoned that, because that never was scaled. It would take me forever to program.
How long did that take?
It was slow. It was slow. So I said, well, I'm only off by a little bit. I think the story challenge that year was, what was that? It was probably 29K. But I was on a 32K chip, and I already used up 5K for like all the interactive challenges and the low-level subsystems and everything else. And so it didn't have it. And so you come back to, well, okay, you got to use it, if you could compress the text. But then you're in this trade-off of, well, how big is my decompression code algorithm implementation in code versus how much space do I save? And so the ultimate solution there was I needed to find the absolute smallest decompression solution I could come up with that gave me, at least a 10 or 12% compression ratio, because that's really all I needed. Bit packing ended up being my answer. I made sure that all of the text for the story challenge was in the 127 characters of ASCII, and I bit packed 7-bit ASCII into 8-bit bytes. On average, I saved about 11% doing that. And that was just enough to get it all to squeeze in. And the amount of code it took was like 100 bytes of code to decompress it. So I wrote a Python script that would do all the compression into C code. And then I only needed like 100 bytes of code within my firmware to then decompress it on the fly.
I wish I could mind meld all of, Vulcan style your brain for all the little hacky insider tricks that you've gotten over the course of the years here.
There are a lot. Well, so starting with 2024, I'm using real IR. Mm-hmm. But even real IR isn't, it's a mess to implement at low level, but with CircuitPython, it's pretty easy. But now I have to do it at the low level as well. But on a coin battery, you don't get a lot of range. Well, you can.
Tell us more.
I mean, you can. I mean, you can a lot of different ways, but I found a way. If you've got a LiPo battery on your design, which for 2024 I did. 2025 I won't. Without doing any real like optical work on it, I got 75 feet out of it reliably.
75 feet. That's pretty
good.
That's pretty good.
Yeah.
Yeah. Well,
Solid.
my goal is to get 300 if I can get it.
That's a lot.
I'd like 500, but I'll settle for 300 if I can get it. And so the trick there is, instead of driving the IR LED off of a pin, which is what you normally do, you normally end up taking a pin off your microcontroller, setting it up to 38 kilohertz as a PWM carrier wave, and then turning the pin on and off to create the various pulses you need of IR. That's the fundamental implementation of it. And by the way, again, you have to understand, 5 years ago, I had zero hardware experience under my belt. So.
Yeah, I am super impressed. Have you, out of curiosity, have you played around with any of like the NRF or CC1101 or any other type of RF related circuitry and integrated those into coins, or have a desire to?
No, because of power.
Gotcha.
I'm constantly trying to push the power level down. That being said, Cold Brew does the Fox badges for the Fox Hunt.
Yep.
And I bought one for somebody else because they couldn't get their hands on one, and I said, I'll buy one and then I'll reship it to you. And then they turned out they got one, so then I was stuck with one. And I'm going, well, what am I going to do with this stupid badge? Well, the first thing I did was, guess what? Nuke the firmware, install CircuitPython, and try to figure out how to implement a Fox in CircuitPython. Well, Cold Brew has, if you saw his post from ShmooCon this year, he's redone his badge using my CircuitPython code. Yeah, exactly. We're just one venereal disease away from completely corrupting the entire organization of badge makers. So I mean, I've played with it, but only because it was on other people's badges. It will probably never be on any of mine, just because I'm constantly trying to deal with power issues.
Yeah.
So the trick is, you still set up the pin on the microcontroller to create the 38 kilohertz carrier wave. You turn it on and off and stuff. But instead of that pin going to the LED, the pin goes to a MOSFET, and then the MOSFET is fed directly off the battery. And so you are way over voltage and over current on the IR LED, but it doesn't care because it's getting a fraction, it's getting these pulses. So it never really burns out. So an IR LED might be rated at like 1.2 volts or, 2.1 volts max, something like that. I'm running mine at like 4. If it's got a LiPo, it's got 4 volts, 4 volts and almost unlimited current driving into it. But it doesn't burn out. And so that's how I got 75 feet out of it without any real issue at all.
Have you done any testing right on that kind of switch mode power supply style, driving that to see if it shortens the lifetime of the LED, or are you just like, nah, it's fine, this is a badge, so it's not going to matter?
I don't know how long I'd have to run it for, but I did do the math on duty cycle. So I actually tweaked the duty cycle so it's not 50-50.
Okay.
It's like 20-80. So it's only on for 20% of each pulse.
That makes a lot of sense.
That being said, I was talking to Lady Ada a week ago, I guess it was, and got some input on, I need to really up my game on gathering data about current usage, current as in power.
Yeah. And
so I'm going to be ordering, I guess there's like 2 tiers. For $100 you can get the Nordic PPK2, and for $1,000 you can get what Adafruit uses. Like, I'll settle for the $100 solution. And she goes, actually, the $100 solution works really well. She goes, it's what she's got in her, in her home office.
I think they just moved out to Brooklyn.
They got a beautiful new site. Oh yeah. So not only did they move the company, but they also ended up moving themselves. So for the past 6 months, she's been trying to rebuild her home office.
I can imagine what an undertaking that would be, considering how long that she had spent in her old digs.
Well, and yeah, just how much equipment she had acquired.
It's got to be a
they're
massive.
now in. They're not. Yeah, I wouldn't be. They haven't talked about it, but I wouldn't be surprised if they got some financial incentives to move, because they moved to what's referred to as Industrial City, which is this sort of high tech incubator hub kind of building and other buildings around it and courtyards and all this other fun stuff. So it's a really nice physical location they're in now.
I was going to say, with regards to manufacturing, who do you typically go through?
Well, the only thing I outsource is the making of the PCB itself.
Okay.
And I use three different sources. Well, one is I use it if I'm doing something for somebody else, they end up choosing, and often they choose based on price, which means they choose JLC PCB.
Yeah, I was going to say.
and if their design can be done by JLC PCB, that's fine. I don't have a problem with it. I did my original prototypes for 2020 with JLC PCB, but they couldn't deliver at the time. They couldn't deliver the quality of silk screening that I needed. And ultimately, when I changed the design, I added a feature. I added side plating to the pads. They couldn't do that at all. And so the 2020 eChallenge coin PCBs were manufactured by PCB Way.
Wow. Okay.
Now I stayed with PCB Way for a while. I even used their PCBA service for 2021 and learned my lesson. They did a great job, but the problem with outsourcing PCBA for me, which is printed circuit board assembly, is you have to know up front how many units you want, because going back for a small number of additional units is expensive. And I didn't know how to estimate how many units I needed, and so I overestimated. And so I still have some 2021 assembled boards in a box. They haven't been programmed or flashed, but they're there. Quality of the work, great, but what am I going to do with them? So for most badge makers, I still say you don't want to bring assembly in-house, because up front how many units you're going to do. I'm only going to do 50. I'm only going to do 100. We're shooting for 250. It's like, so for this gig that I'm doing, if I didn't have the equipment in-house, I would have easily outsourced it, because I knew right up front how many units I needed. And he goes, you need 450 units. Here's the breakdown. So that would have been easy to have somebody else do the assembly work on. But now I have all the equipment in-house, so I do it in-house now. When I went to do 2022, that was Sarah and the Nightclub Riddler, I wanted a poker chip style aesthetic to it, which is why it's got
the are you talking about the actual poker chip like looking touchpads, like similar to the Lego, along with the dice?
No, it's got the dice and the jokers, and the lips are from
Harley Quinn.
Yeah, Harley Quinn. Yeah, so the lips are actually Harley Quinn's lips in the middle of that.
Oh, okay, nice.
Oh,
but to get that aesthetic, I wanted black on red. And now you can go to sort of advanced manufacturing modes with PCB Way and get black on red. But I jumped over to PCB Buy for that capability. And I stayed with PCB Buy to do the 2023, which was the Simon game. But what's interesting about the Simon game was Panda, and I'll get the other name in a minute. We had all, for what would have been DC31, we had all decided we wanted to go full color. And we chose completely different solutions we didn't know each other. We hadn't talked to each other. We were all doing this sort of on our own, on the slide, because we wanted it to be a big surprise to everybody. So we all ended up coming out with full color that year, using three completely different solutions to making full color. So we did a panel session last year at DEFCON 32, which was a blast. I think we asked each other as many questions as the audience did. So Panda had gone with what the PCB shops are now doing. He did UV printing onto PCBs. And I talked to him extensively about how he did that. And one of the problems you have with UV printing is it doesn't necessarily like reflow temperatures. Reflow temperatures are in the 450 to 500 degree Fahrenheit range, right? 225, 240 degrees Celsius. And inks don't behave well at those temperatures. And so he fought a lot with color shifting of his inks, but he's got a real big company behind him, because they actually make their own PCBs, right? They actually They do everything in-house. They don't even like order blank PCBs from someplace else. They order blank FR4.
Wow.
And they do all the PCB work in-house. So I mean, there's a whole PCB manufacturing. It's basically an Indian PCB manufacturing company.
Okay.
And then he's tacked on the side all this badge work. And what's staggering is if you look at his badges, the vast majority of them are still hand soldered. You know, it's the Indian sweatshop model of doing badges.
Oh man.
But anyway, it's like I'm going, no wonder none of us can compete with him when it comes to doing badges.
Right.
He had done UV printing onto PCB substrate, and it looks great. And he's worked through the color issues, and he can tweak it because he can run one board through and know that it doesn't look the way he wants it to meet the aesthetic. And so he'll go and tweak the colors and run another board through, and then he can dial it in to get what he wants. But he can also do his UV printing after assembly if he wants to.
Yeah, I wasn't able to attend that year. And I do recall some of those colored PCBs coming out. I want to say the other guy pulling it up here was Hamster. Was the other guy Hamster?
Yeah, Hamster. So he went down dye sublimation, which is you print onto a piece of material and then you iron it onto. It's often used for doing T-shirts. And then you iron it onto whatever your finished product is, and you peel the paper back off. And
that's got to be annoying.
Well, it is, and there's a very fine line between enough heat to do dye sublimation and not so much heat as you mess up the printed circuit board. The temperature he's got to do is just below the melting point of the solder, but it's got to be hot enough. So he can't do dye sublimation onto an unpopulated board because the dye sublimation it all turns brown if he tries to run it through reflow. So that was his solution, dye sublimation. Having talked to Panda, I wanted a solution that could handle as much heat as I wanted to throw at it. I literally silk screened the PCBs.
Wow. So did you set up did you have one of the smaller ones you can buy from a craft store and you just did the UV mask and the whole nine and then just kind of set it up assembly style?
So the challenge is normally when you're doing a T-shirt, you're doing something that's, 300 millimeters across, 30 centimeters across. So you're talking, 8, 12 inches.
Yep.
When you're talking a PCB that's all of 47 millimeters across, you got to be really fine detail, and B, you got to be really accurate with your laydown. Well, what piece of equipment do most badge makers have for laying something down with, 0.2 or 0.1 millimeter accuracy? We almost all have these manual solder printers, right?
Yeah.
Which are ostensibly nothing different. It's a silk screening solution, except we use stainless steel screens instead of, So I literally took that and ordered high resolution or high mesh count silk screens. So I started at 230 and I'm now running 305s. And so that's literally the number of holes per inch. So in essence, I now have a 300 DPI screen, and I learned how to do the emulsion, and I learned how to do the exposure, and I learned how to wash it out. So I had, screens that I could reuse. And then I put them in my my manual solder paste printer, and then it's got knurl knobs, which allow me to dial it right down to sub-millimeter accuracy. And I use solder mask ink. Well, it gets weirder than that. So solder mask ink is UV cured.
Right.
So I went out and picked up 50 or 75 watt UV LED grid light, and it was taking forever to cure the UV ink. And so I talked to Panda, and I said, so Panda, how do you cure your UV inks? Because they're doing printed circuit boards, they must be able to cure UV ink. And what I found is his UV lamps are 5 to 10 millimeters away from the top of the board. And I went, oh, I've got to get my UV lamps a lot closer to the printed circuit boards.
How far away did you have it?
I had them probably 6 or 8 inches. Enough I could get my hand under there to pull the boards out and push the boards back in. So,
gotcha.
I was like,
have a tray solution.
I was like 2 orders of magnitude off on my distances.
So you're like a MacGyver now of PCB manufacturing.
But the downside to silk screening as compared to dye sublimation or UV printing is UV printing does all the colors at once. dye sublimation does all the colors at once. Mine is one color at a time.
Yeah, that's the rub.
Yeah. And so if you were to look up, I did a modular synth out of PCBs. Well, actually, what I did was I created what I refer to as hardware UI widgets. One was an XY touch panel. One was a circular touch wheel like you found on the old iPods. One was a VU meter. One was a set of rotary encoders with colored LEDs behind them. And one was a little tiny display. And all of them were I2C controlled. And so you could mix and match these UI elements and you could drive them from CircuitPython or anything that would talk I2C. Because I was only ever going to do, one batch of like 5 PCBs for each of the units, I went through and did the whole fountain flow on them. So they're all kind of organic looking. And then I was going to use the technique for the DC Next Gen badge this year, but at the very last minute, we got a change request from Dark Tangent, and so there was no way I could do it with the colors that he wanted or the colors he required.
Yeah, I did see your initial postings on that badge. Looking forward to seeing that here in the coming year. Are you going to be working it again this year?
Oh, yeah, I'm gooning for them again this year. So the badge this year is completely unrelated to the badge last year.
Okay.
The badge last year was an idea that I'd had in the back of my head for a while. I'd even submitted it as a contest the previous year. So it was the concept behind that badge was submitted as a contest for DC 31, and it got accepted, but they didn't tell me it was accepted until May. I said, there's no way I can finish this now. And so I said, no, I appreciate it, but no. And I said, I'm going to be totally honest. I'm not taking, I don't want you to take offense, but is May a typical time frame for approvals on contests? And they go, yeah. I said, okay, fine. Then it just tells me I'm not going to resubmit this as an idea for a subsequent year, because it's too late to try to do all the manufacturing and code and everything else from May to August is no. So I had this idea of a learning badge or a teaching badge. And I knew that it was going to be Python based because that's the easiest one to learn and teach. And also it's the one that is most repurposable into a lot of cyber and security and infosec and related industry jobs. So if you're going to learn Python, you're going to actually be able to use it for something real. And so I had this idea, and I said, well, it could be a contest. It could be, we did all sorts of different things with it. And then when I found out that Dark Tangent and BSI Lab had been talking to create what originally was going to be called DC Kids, I reached out to Bia and said, you guys ever thought about doing a badge? He goes, oh my God. Except in a much higher, much more energetic voice. I don't know how she has as much energy as she does, but she does. She just got back from Prague.
Yeah, so I saw.
And so anyway, so we started talking about it, and I designed the entire DC Kids badge, the whole graffiti theme, sort of the grunge look to it. And then they came back and said, we're changing the branding. We don't want to call DC Kids because we don't want people to think that it's, for like 5-year-olds and it's a daycare center.
Right.
So we're going to call it DC. We're going to call it DC Next Gen, which it really grated on my nerves because Next Gen is such an overused and generic term now in most industrial companies. But
it's like that 90s campaign ad campaigns for everything with an X in it.
Yeah, exactly. So I finally got on board, but but that kind of changed the layout of it and all that stuff. But thankfully I had created a font. So the font that you see on the DC Next Gen badge is actually a hand created font by me. So I own that font. It's open source because I open source everything. But it also meant that when they said, okay, we're going to go from DC Kids to DC Next Gen, it's like, okay, just type in new letters and render a new PCB out the other end. But then there were some hardware changes because each of the letters on the artwork, those are all touch sensors. So the D, the C, the N, E, so it's got 9 touch sensors on it. But the graffiti tag on a concrete wall with perspective view and all that stuff, that was able to be preserved. So that badge did start out as, a long-term, I want to do a teaching badge. And so that's how that was the genesis behind that one. And then, of course, I created the workshops for it and taught intro to Python and hacking the badge at DEF CON 32.
Yeah, one of the things I think that we both are generally interested in is trying to, I don't know if you've ever heard the old adage, like building knowledge is the first step towards creating wisdom, but sharing is the first step towards community. I think both of us in our formative years didn't always necessarily have some of that community around. You know what I mean? Now I think it's probably a little bit different now with the internet, and it's definitely different with how common and ubiquitous a lot of the kind of nerdy, hacky STEM tools that are out there. I mean, I think really Ada broke through on that in like, what was it, 2009, along with like the makerspace. And now it's like you can't throw a rock but for finding somebody else's new microcontroller project. And I love that. You know what I mean? But a lot of the, I think, impetus behind us creating the show is to try to see if we can't make sure we try to give some of those tips and tricks to some of the newer people coming up, or what would the advice be that we would give to our younger selves. And I think like you're dropping like a master class for would-be hardware engineers. And I love that. I love that so much.
Well, it's hardware and software. And I agree. If I look back on the things that got me to where I am today, they come down to two things. A, people answering lots and lots of stupid questions, or at least naive questions, and B, mentors.
Yeah.
And I push the envelope on what I define as a mentor, and a lot of people don't quite grasp this when it comes to their careers. Normally, when they think of their careers, they think of a mentor as the person who's, above them. And it's like, no, you don't want the person who's above you. You want somebody who's 3 or 4 levels away from you. And so when I was sort of the advanced tech, senior software engineer or 1 level above, that kind of thing, my mentor was a general manager at the corporation. I mean, just way above me. And so when he and I would talk, we'd only be able to talk once a quarter because their time is incredibly valuable.
Sure. Limited.
But, the insights they would give were they opened up my understanding of what I was experiencing, because I could now see it from somebody who was in a completely different perspective with a whole different set of goals, but their goals eventually do trickle down to my goals.
Right.
And like one of the greatest pieces of advice that I got from one of the general managers that was a mentor for me was, by the time you are sick of the message, you've only reached 1/3 of your audience.
Wow.
And what he meant by that was, if you're trying to convince people of an idea, you have to say that idea exactly the same way over and over and over and over again, because the people you're saying it to are different every time. So you're sick of the message, and you want the tendency you want to do is start to change the message to make it more interesting.
Mm-hmm.
And his point was, don't change the message. Keep repeating, because what's going to happen is a couple of those people that you'd given the message to at 2 different times are going to have coffee and go, I heard this, blah, 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 blah. And goes, I heard that exact same statement. But if you change your message, they're not going to realize that they're talking about the same person and the same thing.
So it's kind of taking a body of its own.
Yeah. And it's like a tagline, right?
Right.
If most companies that come up with a tagline don't change the tagline, even if their ads change and everything else, the tagline stays the same, because it's the tagline you remember over and over again. When you walk in to find a product, you remember the tagline. You don't remember the commercial necessarily, because the commercial kept changing every 3 months. So his point was, by the time you're sick of the message, only 1/3 of the people have heard it. So you got to stay on message, and you got to repeat it exactly the same way every time. Work on your elevator pitch. It's going to make a big difference. So mentors for me have always been a big one. But you're right, though. The internet has opened up a community where if somebody is willing to answer questions, they're going to have an impact on people, because people will find them.
Right.
Whereas before the internet, the guy in the UK was more than happy to talk to people, but the number of people he might potentially encounter without the internet might be, if he's lucky, would be on one hand 5.
Definitely, especially
Probably
with niche
less
interests. You know what I mean? It's not too common. With the exception of a couple of notable areas within the country in the world that you can easily pop into a conversation. That's really how DEF CON started. You know what I mean? So a lot of those maybe neurodivergent and other people, other sometimes marginalized folks wanting to deep dive on some of the nerdier things that they were getting involved with. And I'm thankful that they did. And a lot of those traditions carry forward to today. Although some of the platforms and stuff have changed, the technology changes, it's still great to be able to link up with people of that kind of similar outlook, similar mind, and thankfully different outlook and different mindedness too, to help you either up the game on what it is that you're going after, to your point, and talking to those senior mentors, or be able to just give you a little bit of a peek in that deep expertise in a field that you might not be a deep expert in. And it feels like you can level up your game a lot quicker that way, in my view.
Yeah. And, you know, there is still something to be said for in-person interactions.
Oh, definitely.
When I was at DEF CON and doing the workshops for DC Next Gen, you know, I could tell that there were some people who got it. And it was like, okay, fine. And then, you know, and I don't care how many people are in the room. I'm looking for that one that just goes, oh my God, you can see the spark just explode in their eyes, right?
Yep.
You know, and there was like, there was literally one of them out of the 150 or so registered DC Next Gen attendees, you know, people that had the badge and were out, you know, visiting the villages and interacting and stuff. You know, I saw one. They just, you know, I finished my workshop and they go, well, so how would I do this? And I went, and
you got the spark. You got the spark.
I went, that question is 3 levels removed from what I covered, which meant during the course of me talking, they solved 2 out of 3 problems already. It's like, yes, there's a spark there. Let's go find it.
The knack,
you know, and so there's, and so whenever possible, I answer questions and I tell people it's not that I'm that smart. It's just I've already made all those mistakes already.
For people who are getting started with things, what kind of resources or communities would you recommend them dialing into? And are there any other makers or video channels or resources you'd like to share that come to mind that I can throw there into the show notes for folks?
Yeah, I mean, I don't want to sound like an Adafruit fanboy, but the amount that they do that's open sourced and the amount that they contribute to the community is staggering.
Oh yeah.
That being said, if you are on social media, you know, branch out a little bit on Instagram and others, and you will find people who are willing to answer questions. You'll also find a lot of people who are just, you know, trying to be influencers, and, you know, that's good for them. That might give you some ideas, but they're not very helpful in getting started. You've got to find the ones that are willing to respond to direct messages or comments, you know, even just comments. If they'll reply back to comments, you've got a fighting chance of getting some good, useful information. As much as I understand a lot of people are not big into Discord, except for gamers, Adafruit's Discord server is really hard to navigate, but incredibly useful, because Adafruit staffs that Discord. It's not like a lot of Discords where it's kind of all volunteer. Adafruit has, you know, they have volunteers who have signed up to be volunteers, but they also have staff, you know, paid staff who get in there and answer questions and will guide you through stuff and help you through problems, whether that be coding for Arduino or coding for CircuitPython or doing hardware design. And, you know, that's probably one of the things that I wished I discovered earlier.
I have always loved their take on like releasing hardware with all of those tutorials. Some of the old ones, like on the old site, were a little bit but man, I love the tutorials and stuff that they release in the forums they've always had, especially coming from like when I first got into Arduino, I was trying to learn stuff on the AVR Freaks forums, and those guys were assholes about everything.
They are. They you know, you've got to go in with really thick skin, and you've got to play a game of chess where it's like, okay, this is the question I want to ask. What's the likely response to that question? How can I change my question so I don't get those responses? Whereas, and again, this comes back to Adafruit funds and staffs, you know, people to write tutorials and stuff. I had posted, this was probably back in my Instagram days, I don't remember, about running open source firmware on the MC30 or whatever it is. It's this little tiny, like 40 millimeter by 40 millimeter reflow hot plate. Tiny little thing.
Oh yeah, I remember that guy.
Adafruit.
Yeah.
Adafruit, right? Well, I was running Iron OS open source on it. And they said, would you be willing to do a write-up? I said, sure. And they said, we'll pay you for it. And I said, no, here's the deal. I'll do the write-up. You donate through GitHub to the Iron OS project. And they said, okay, we'll do that. We'll donate what we would have paid you to the Iron OS. And so I've done that a few times where it's like, I'll write something for you, but here's the deal. The money goes to whoever inspired me on this thing.
That's pretty cool.
So yeah, it's they do a lot of really cool tutorials. They have a lot of staff working on this stuff. And from a hardware designer, I was just on. I just recorded a podcast for Paul Cutler. He's bringing back the CircuitPython show, but he's doing a pretty well curated series this year. And he wanted me to talk about hardware, which was odd, but I'll talk about hardware. So one of the things that I spoke to him about was the fact that Adafruit, above and beyond when it comes to open sourcing all their hardware, all their software, everything else. So anytime I'm trying to design a new board and I'm going to be working with a new chip, I go see if Adafruit's ever created a product that does that. Because Adafruit will publish the schematic, they will publish the parts list, they will publish the actual board layout, so I can see if there's any little quirks that they did to get it to work they wanted to do it. And because of that, my first shot on almost every board works. It may not do everything I want, but it basically works because, as Paul Cutler says, standing on the shoulders of giants.
Yeah.
Adafruit opens up all that stuff. And Adafruit's not the only one. I was surprised to find that Waveshare, who is big into displays and display breakout boards and stuff, Waveshare publishes all their stuff too.
I think I've used them too much. Have you used them, Del?
I have. I recently screwed up hard modding a Switch where I bricked the ever-living shit out of my Switch using one of their RPI 2040 boards. So I've used them a little bit, but not like a whole bunch for projects and stuff. I didn't know that they publish all of their documentation, schematics, and stuff like that.
Yeah. So for me, the one that the latest one that kind of fits this bill was I worked with ePaper displays for last year. So both the DC Next Gen badge, which has a tricolor ePaper display, and the Explorer badge, which was the 2024 eChallenge Coin Explorer badge, has a black and white ePaper display on it. ePaper displays require a driver circuit, and it's a very specific circuit, and it has to work a very specific way, because what it's doing is it's boosting voltages in a couple of weird ways that the display needs to do that refresh. And so both Adafruit and Waveshare published their implementations of it, and they're not exactly the same. And so I implemented a test board that would let me go between the two implementations based on what display I had, because at that point I hadn't figured out who I was sourcing my raw displays from. But I never would have gotten that. There wasn't a chance in the world I would have gotten it, let alone gotten it right on the first shot, if I not had access to Adafruit and Waveshare's open source content for hardware.
And so some of the stuff that they do that I like as well, especially on the Adafruit side, I'm a big fan of, if either of you do or don't watch, Deska Lady Ada on YouTube, where she'll just sit there and show her process for making and refining some of the products. And I don't know if surprised, but I don't know, it just kind of caught me off guard when one of the times she was like, okay, well, here's the reference circuit in the data sheet, so we're just going to do that. Obviously it works. We're not going to try to, reinvent the wheel or anything like that, and just would straight up rip off the data sheet. It's okay, that makes sense, right? And it's kind of that same vein. It's well, I'm probably not going to design this circuit better than so and so or whoever it was, especially if you're kind of hacking stuff together, like a beginning maker. So having those resources is spectacular.
It's funny you mentioned that, because I haven't found it. I saw it, I forgot it. Somebody asked a question on the Badgers Discord, and I went back to try to find it, and I cannot find it anywhere. But the tail end in December, she created a bunch of Sparkle Motion boards.
Oh yeah, I just saw.
And one of the interesting things about the Sparkle Motion boards is it handles high current, and one of them has got a 5 amp slow blow fuse on it that will reset on its own. And she showed an oscilloscope and a DC power supply, and showed as she started to crank it up, she showed the oscilloscope output, and sure enough, you could see where it blew and it dropped down, and then you could see when it finally cooled off and it popped back up again. And there was this question on Discord about how fuse circuits work,
And I went looking for that chunk of video clip, and I still haven't found it. But I'll go back and just like literally slog through like 5 or 6 episodes of The Desk of Lady Ada to find that, because it was such a great visual example of what the heck is going on. And I will admit, I did a training course I wrote an entire workshop series called AVR Coding 101 for how to code low level without using Arduino or anything else for the new tiny AVR chips, like the AT Tiny 1616 and the 80, the 812 and the 412 and the 212 and all those things. And one of the things that I wanted to be able to demo in there was some stuff off of an oscilloscope. And since I was live streaming, I was like, okay, how am I going to do this? And so I finally ended up, I literally upgraded my oscilloscope, not because I needed a particular, I didn't need like higher megahertz, and I didn't need higher sampling rates. And yeah, I kind of did want 4 channels on it instead of 2, but the biggest thing I wanted was it has a web interface on it. And so I literally can project it into a browser and then browser into OBS so I could show what was going on.
Oh, that's clever. Yeah, to record it.
And so, yeah, it's kind of handy to have. My bench has gotten kind of weird because it's as much equipment I've chosen because I can use it for teaching as it is because I can use it to do my job.
You don't have to share a picture if you don't mind of maybe like some of your bench or setup or something like that. I'd love to throw that in the show notes. I'm sure it's an awesome sight to behold.
Let me clean it first.
Fair enough.
Let me clean it first.
It must look similar to mine.
Yeah. Well, it's funny because I have really kind of 2 stations, right? There's the station where all the electronics happens, and there's a station where most of the code happens. I'm at the code one right now.
I love sitting inside people's workshops. There's always a moment where you go, ooh, what's this? What's this? Feels like you're Jack Skellington or something there, like on The Nightmare Before Christmas, and inevitably, I'm like, ooh, I want one. But in any event, I believe it is time for us to wrap up the show here. It's great having you here. Thanks for dropping us all of the knowledge that you have today. Let me, I guess, ask a final question. Is there any plugs or shout outs or anything? And is there any place you'd like to share where people can find you and interact with you?
BradanLane.com for almost all content. And then that links off to everything else. That has links to the foundation, that has links to all the Sarah Cladlow content. God forbid you actually want like a real UX designer. It has, it has my shingle out there too.
Nice.
It also links off to my GitLab repositories. So everything is there. And I am Bradan Lane everywhere. Discord, Signal, Blue Sky. I still have my Twitter account though. I have abandoned it. About once a week I go over and find out if anybody's posted anything over there or asked me a question. And that's how I found out that Cold Brew had tagged me because he used my CircuitPython code on the Fox badge this year. But yeah, Bradan Lane everywhere.
Well, right on. I think I'm going to probably be hitting you up maybe over the course of the year here for maybe a design consult or two, if you don't mind.
Yeah, and
holy cow,
so
I did not think that this 15-minute conversation was going to be such a pleasure. It's been an absolute pleasure to talk to you. And Del, is there any other thoughts, questions, anything on your mind?
No, I think we covered everything.
No, we didn't, but that's all right.
Well, yeah, I was going to say, we didn't cover everything. We covered everything that I'm going to reasonably be able to get away with and still be married at the end. By staying here for 7 hours.
Yeah, okay. You guys have a good day.
Yeah, you too. Thank you so much. And yeah, I'll hit you up, sir.
Okay, talk to you later, guys. Bye.
See ya.
Bye.
Bye.
repp.show. Nerd Talk IO.